Hi, I'm taking Paul McWhorter's vPython class. We're on lesson 14 and we're modeling a clock. Um, this week's homework was to redo our minute marks so that they were boxes instead of spheres, and also to put hands on the clock. We can get to the code and see what we were doing. So basically, Paul wanted us to keep it parametric, so I started off with a radius of the clock and made everything based on that, so that if that changed, we'd be good for that. Like I said, I did make the rate of the clock go minus in the Z direction so that the clock face would be at 0Z. So then when anything we put on the face of it, if we went in the positive direction, that it would show up. So that by going negative on that, just the clock face, everything else is positive. That worked out. So I already had the cylinders for the hour marks last week, but I had spheres for the minute marks, and Paul really said he'd like us to do boxes, so we learned a little bit more about axis vectors. So basically, the only difference is between the box and the cylinder is one's position starts at the end of it, and one position in the box starts in the middle. The cylinder is at the end, and the position is in the center of the box. So basically, it's the same thing. You take care of doing that. The difference is that with the cylinder, we can multiply our vector, our sine and cosine vectors, by the length that we want our item to be, and our length is added right into it. With a box, you have to, because it's in the center, you really can't get a length out of it, so you just have to use what they call a unit vector. Just do the sine and the cosine in there, just to give a pointer to the direction you want to go, and that's actually along the length. So then and then you just use your size vector, and everything rotates. Your box rotates around your axis that way, and but you have to just have your size as a separate item. So that worked out fine. I just both ways are good. This one, you just get to combine everything and get your length into your axis, and you don't have to worry about specifying the length later on in your cylinder. So anyhow, while I was doing the hour marks, I decided, well, you might as well put the numbers in while we did it. So we haven't done texts, or maybe we have, but I just wanted to do the text on here. And the thing about text is that your position vector, if you align it to center, like use align center as opposed to right and left, your position is at the very bottom of your number, but in the center. So whatever height of your text is, that your text is going to be above whatever your position is. And for our clock, we really we're calculating the center of the right on target. So you have to use vector math, and this actually lowers it by half of the height of your numbers, and that gets you back where you need to be on that. So it's something new I had to learn this week. Anyhow, and then also just incrementing our numbers, and starting at 12 and I'm actually incrementing, but then using the modulo operator to keep the numbers 12, then 1, 2, 3 on and on up. So that worked out fairly well, and you'll see how that works up a little later. For the hands, clock hands, I just used 3 arrows. Paul said just do minute and hour hand, but I figured do a second hand while I was at it, just a couple extra lines of code. So basically all you're doing with that is you're just doing like an increment thing here. So we're incrementing at rate of 100. So you're incrementing 100 times a second. So basically I figured, or you're showing it 100 times a second. So I'm incrementing our time by 1/100th of a second, so that we're, that after 100 iterations, you're move 1 second. So, and then we're just using that to calculate the position, our second position around our 2π, like we do for everything else we've been working on. And basically, we're dividing by 60 because there's 60 seconds in a minute. And then we're just calculating the position of the second hand the normal way we do it. And then makes it real easy. Once you got that, then you know that your minute hand moves 1/60th the speed of the second hand. So your minute position is going to be up there. So you just do the same thing and you just calculate your minute arrow. And then you know that from your minutes, you're going to 1/12 of the speed for the hour. So just simple math along the way to do that. And we can actually show you it working. All righty. Like I said, the second hand's updating 100 times in between each of those minute or minute marks on there. So as you can see, the blue minute hand is moving. When we get down to 6, it should be about halfway in between the 2 marks. And we'll just wait and show that it goes all the way around to 12. It'll be on the other mark. It's hard to see, but if you let it run, the hour mark does the same thing. And the hour mark will be on 1 by the time the blue minute mark gets all the way around. But we're not going to have time to wait on that. So. You can see it working. I guess I could increase the rate on that to show you, to make sure that you understand that you can see that the minute mark is moving too. So we'll go down and we'll change the rate. And 1,000 might get us around so that you see it to move a little bit. So this is 10 times normal speed. We'll let it go just long enough so that you can see that it's all the hands are moving. You can actually see it moving a little bit. So by the time the minute hand gets to 12, it should be at the first tick on the clock. So we'll let it go until that long. Anyhow, while we're waiting, I want to thank Paul for all he does and look forward to more lessons. It's always fun to keep up with this stuff. Cuts into my free time some, but it's good to learn something. We're coming up on 10 and one, like say, 1/12 of the way. So if we get to 12 minutes, we'll be good. And one more time around, and you can see that the hour hand's pointing right to first minute hand now. So that's working. So thanks for watching. Talk to you later.